Okay, today we're going to be putting together our slopes and our y-intercepts to create an entire equation. All right, first thing I want us to pay attention to is that we are making a linear function. And the thing that is special about a linear function is that it has a constant rate of change. And that's why we can make one whole equation for it. All right. Our a value, when we're starting after the equal sign, we start with our starting value. Remember, this is also called the y-intercept. We've practiced this over the last couple of days, and now we're going to put it all together. The b value, the thing only with, or the thing with x, and only the number though, only the coefficient, that's our slope or our rate of change. All right. One thing I want us to point out, the y equals sometimes will be something like f of x. And all that means is that this side of the equation is the output. And our x here stays x, or whatever variable the question tells us, and that's our input. We're going to look at a couple of examples that you guys looked at yesterday around the room in our our green and our yellow circuits here. Starting with this graph here about the account balance and the months. So it says the following graph represents how much money Sarah has in her bank account after M months. If we take a look down here, M is down here on our x-axis, which means that M, or months, is our input. The amount in her balance is like our y-axis, that is our output. All right, some things to notice is that this line is decreasing. So we're going to have a negative slope. All right. Part A, for part of our learning target from yesterday and the day before, is to state the slope. And when we've got a graph, we're going to do our slope as rise over run. And we're going to pick 2 points. And we see that it's going down 1 block and over 1 block. But when we're looking at the scale here, we're not talking about going down $1. Our scale here is $400. So we are going down $400 and over to the right 1 month, which means our slope is negative 400 for down over 1, or if we're talking about it as a rate, we're talking about negative $400 per month. So she is spending her money. The y-intercept is where it crosses the y-axis, which, if you recall from yesterday, or if you got it right yesterday, that's at 4,800. Oops, sorry. And we're talking about she started with her bank account in this span of 12 months at $4,800. She ended at the end of this month, or this year, with $0. She just kept spending and spending. Okay. The new part for today is to write an equation to represent A of M, or the amount of money. So that's our output. That's like our Y equals, in the account after the mth month. That's our input, or like where we would normally have X. Okay. Typically when we're doing this, we've got Y equals A plus BX, right? So we would have Y equals our starting value, 4,800, plus our slope, negative 400 times X. But with the regions, they want you to use the specific variables that they tell you. So instead of Y equals, for our output, we're putting A of M equals 4,800. Our numbers are going to stay the same, minus 400. And then for our input, instead of X, we're going to put the letter M. So A of M equals 4,800 minus 400M. This is a way that we could predict and we could tell how much money in her account after however many months. All right, flip the page. Number 2, Mr. Gammon orders a pizza with cheese and one topping. It's pepperoni for $6.50. He then adds peppers to the pizza and the cost increases to $6.75. After he adds a third topping, the pizza costs $7. Assuming that this pattern continues, Part A, create a table of values to represent the number of toppings T and the cost of the pizza C of T. So our toppings is our input, like our X, and our cost of the pizza is the output, like our Y values. Okay. So we're going to just read it. A pizza with one topping is $6.50. So under one topping, we have $6.50. The next sentence says that he adds another topping and the cost increases to $6.20 or $6.75. After he adds a third topping, it costs $7. So if we take a look here, we're noticing that the pattern is adding 25 cents per topping. So to get 4 toppings, we would add and increase the price another 25 cents, and the cost of the pizza would now be $7.25. So our rate of change, or our slope, is that 0.25. We are adding 25 cents every time. All right. State the starting value. Remember, the starting value is when X is 0, or the cost of a pizza with no toppings. So we have to work backwards. So we're going to take away 25 cents and find that when there are no toppings, the pizza costs $6.25. And now we need to write the equation. Write an equation to define C of T, the cost of the pizza. That's our output. So that's like our Y equals, but instead we're going to do C of T equals. After T toppings, that's our input. So instead of X, we're going to write T. So we've got, starting with our starting value, C of T equals our starting value, $6.25, plus our rate of change, 0.25, times our input, which is the letter T. Question 3. Each day, Tony records the height of a plant for her science lab. Her data are shown in the table below. We've got height and we've got days. Height is like our X. Days are our X, height is our Y. All right. If we take a look at this, we see that there's a pattern of adding 1.5 centimeters every day. It's growing at a nice constant daily rate. All right. I need to work backwards in order to get to day 0. What's our starting height of the plant? So I need to take away 1.5 from 3. And we end up with 1.5. So when we're writing an equation to represent h of n on the nth day, we're going to start h of n equals, and we're starting with our starting height of the plant, which is 1.5. Our pattern, or our rate of change, is increasing 1.5 centimeters per day. And we represent days with the letter N in this specific example. This really should say part B. Use your equation from part A to determine how many days, so that's our X, we're trying to find X, or N in this case, it takes for Tony's plant to grow 16.5 centimeters tall. That's our height, or our output. So we're saying our output is 16.5. We need to find the input. We need to solve for N, which is why we've practiced and practiced and practiced solving our equations. Take away 1.5 on both sides. We get 15 is equal to 1.5 n. To get n by itself, we need to divide by 1.5. And we get n is 10, meaning that on the 10th day, The plant will be 16.5 centimeters tall.